We will cover the flight instruments system of the ATR. First, we will start out with a brief system description. Next, we will look at the individual components of the flight instruments systems, including the Air Data Computers, or ADCs, the Attitude and Heading Reference System, or AHRS, the Electronic Flight Instrument System, or EFIS, the flight recorders, and the aircraft clocks. Aircraft systems require air data information such as airspeed, vertical speed, and pitot-static pressure values. This information is provided by the Air Data Computers, or ADCs. An Attitude and Heading Reference System, or AHRS, provides attitude and heading information to various subsystems. For example, the radar antenna is stabilized by using attitude information that is provided by the AHRS. The Electronic Flight Instrument System, or EFIS, processes the information from various sources and displays it to the crews through the primary flight displays, or PFDs, the multifunction displays, or MFDs, and the engine warning display, or EWD. There is also a standby display called the Integrated Electronic Standby Instrument, or IESI, that displays the same information as the PFD. Since everything in aviation is time-related, the aircraft is equipped with two clocks. There is one clock located on each side of the flight instruments panel. The aircraft is equipped with a cockpit voice recorder, or CVR, and a solid-state flight data recorder, or SSFDR. The CVR records audio from the flight deck. Audio is collected from an area microphone, as well as through each remote-controlled audio unit, or RCAU. Various aircraft parameters are also automatically recorded by the SSFDR. The ATR is equipped with three independent air data systems. There are two main air data systems, which supply information to the Air Data Computers, or ADCs, and one standby air data system, which supplies information to the Integrated Electronic Standby Instrument, or IESI. ADC-1 is primarily powered by the DC emergency bus, and receives backup power from the hot emergency battery bus. ADC-2 is powered by DC bus 2. Each ADC receives static air pressure, total air pressure, and total air temperature through a dedicated static port, pitot-static tube, and a total air temperature probe. These probes are located on the left and right sides of the forward fuselage, and are electrically heated. The information provided by these probes is processed by each ADC. Each ADC then calculates vertical speed, indicated airspeed, true airspeed, total air temperature, and static air temperature. Each ADC then supplies the calculated data to Core Avionic Cabinets, or CACs 1 and 2, AHRS 1 and 2, Transponder 1 and 2, the display units, and the multi-purpose computer, or MPC. The CACs pass the calculated data to the Engine Electronic Controls, or EECs, the Pressurization System, the Anti-Ice System, and the Multifunction Computers, or MFCs. The standby system consists of two static ports and a pitot tube. These probes directly supply airspeed and altitude information to the IESI. Attitude and heading reference information is provided by the Attitude and Heading Reference System, or AHRS. The aircraft is equipped with two main systems, AHRS-1 and AHRS-2. In addition, there is a standby system in the event of a failure of both AHRS-1 and 2. Each AHRS receives inputs from an associated flux valve and the ADCs. The flux valve is a unit that measures the aircraft's magnetic heading. AHRS-1 is primarily powered by the DC emergency bus. DC bus 2 provides backup power to AHRS-1. AHRS-2 is primarily powered by DC bus 2. DC emergency bus provides backup power to AHRS-2 on the ground, and DC bus 1 provides backup power in flight. The PFD and ND receive the following information from the AHRS: attitude, heading, lateral acceleration, and vertical speed. This information is also sent to the autopilot and weather radar. When the aircraft powers up, the AHRS needs a few minutes to align. When the AHRS is not aligned, the AHRS not align amber message is displayed on the EWD, a single chime sounds, and both master caution lights flash. The failure of a single AHRS is indicated by the amber AHRS message on the EWD. If both have failed, the EWD message is AHRS 1 plus 2. In either case, a single chime sounds, and both master caution lights flash. The Control and Display System, or CDS, displays avionics information to the crew through display units, or DUs. The CDS is managed by the two core avionics cabinets, or CACs. The CDS provides the flight crew with flight information, aircraft environment data, aircraft system status, as well as alerts and checklists. The CDS consists of 6 control panels, 2 switching panels, 2 multifunction control display units, or MCDUs, and 5 DUs. DUs 1 and 5 normally display the primary flight display, or PFD. The PFD displays data related to the flight and auto-flight system. DUs 2 and 4 normally display the multifunction display, or MFD. The reason they are called multifunction is that multiple system pages can be displayed in the MFD upper window. Also, the lower right area, called the Virtual Control Panel, or VCP, can display multiple communication, navigation, and surveillance pages. DU3 displays the Engine and Warning Display, or EWD. The EWD displays information related to flight controls, engines, and permanent data, as well as crew alerts and procedures. The DUs automatically adjust their brightness. A sensor on each side of the DU, measures the ambient lighting intensity. The brightness of each display can be adjusted individually by means of a brightness setting switch. A DU can be turned on or off by using the power switch. A light to the right of the switch is illuminated when a DU is turned on. The contrast of a DU is adjusted by the contrast setting switch. Each pilot has a switching panel that enables them to switch the display on their inboard DU. The display button is pressed to switch the display between PFD, EWD, and MFD. If a DU fails on one side, the associated display button is used to cycle these displays on the remaining DU. It should be noted that in the event of a failure of a DU, an automatic switching will occur. For example, if DU1 fails, the captain's PFD will be displayed automatically on DU2. The PFD display is divided into 6 areas. The top part is the Flight Mode Annunciator or FMA. This area displays Automatic Flight Control System or AFCS information, and is discussed in the module for that system. The left side displays airspeed information. The right side displays altitude and vertical speed information. The center part of the PFD is the Attitude Director Indicator or ADI. The bottom part displays navigation information. The airspeed computed by the ADCs is displayed on the speed tape of each PFD. The speed tape moves up and down as the airspeed varies. The current airspeed is indicated by the yellow tick mark. The airspeed selected by the FMS or the crew is indicated by a speed bug on the side of the speed tape and a numerical display above the speed tape. The speed bug and numerical display are displayed in magenta when the speed is controlled automatically by the FMS. The speed bug and numerical display are displayed in cyan when the speed is manually selected by the crew on the ICP. A yellow airspeed trend arrow is displayed when the aircraft's speed is changing. The tip of the arrow indicates the predicted airspeed in 10 seconds. This value is based on the current acceleration or deceleration rate. The bottom of a red and white barber pole, extending downward from the top, represents the maximum airspeed for the current configuration. The maximum speed is VMOMMO in the clean configuration, VFE if the flaps are extended, or VLE if the landing gear is extended. In the event the aircraft exceeds a maximum speed limit, the flight warning system will generate a clacker sound to alert the crew. Click on the Show Me button to see the flap settings for an overspeed alert. Flaps extension speed, or VFE next, is indicated by an amber equal sign. This is the maximum speed that the next flap lever position can be selected. The flap retraction speed is indicated with a tick mark and the letter F. The tick mark and letter are normally displayed in white. They are displayed in amber in icing conditions. A triangle indicates the minimum speed in the low bank mode, with the flaps up. It is normally displayed in white, but it is displayed in amber in icing conditions. A green triangle indicates the highest of the minimum speed in high bank mode, or the minimum control speed when the aircraft is in the landing configuration. The low speed awareness region is indicated by a vertical bar, extending from the bottom of the speed tape. It consists of a solid red bar, and an amber hollow bar above it. The safe minimum airspeed is the top of the hollow band. The minimum speed is the top of the solid part. This is the speed where the stick shaker will be activated. During the takeoff, the V1, VR, and V2 speeds are displayed in cyan. V1 and VR are indicated by a cyan tick mark and a label. The number 1 indicates V1, and the letter R indicates VR. The V2 speed is indicated by the cyan triangle and the V2 label. The takeoff speeds are set on the takeoff page of the McDo. An amber check IAS message is displayed when there is a discrepancy in the airspeed data from the different ADC sources. A red IAS fail message is displayed in the event there is a loss of airspeed data. This message replaces the entire speed tape. The altimeter is displayed on the right side of the PFD. It also consists of a vertical tape that moves up or down against an index. The current altitude is indicated by a yellow tick mark. The current altitude is also indicated by a green numerical value inside a yellow outlined box, to the right of the yellow tick mark. The altitude box flashes during a climb or descent, when the aircraft is within 1,000 feet of the selected altitude. The altitude box stops flashing when the aircraft's altitude is within 250 feet of the selected altitude. Altitude can be selected by using the Altitude Select knob on the Flight Guidance and Control Panel, or FGCP. This selected altitude is displayed above the altitude tape in numerical format, and by means of an altitude bug beside the altitude tape. Both are displayed in cyan. If the aircraft is VNAV equipped, the FMS can control the selected altitude. In this case, the next altitude constraint defined by the FMS is displayed in magenta above the altitude tape. It is also indicated by a magenta bug beside the altitude tape. The current barometric setting is displayed in cyan at the bottom of the altitude tape. This value is set by the baro set knob on the ICP. The barometric setting value is displayed in hectopascals, as well as inches of mercury. The standard setting is selected by pushing on the top of the baro set knob. In this case, a cyan STD label is displayed in a white box. The ICP has a knob that enables the crew to set the decision heights, or minimum descent altitude. This altitude is represented by a pair of amber horizontal lines on the altitude tape. The landing elevation is represented by the top of the brown area, on the bottom of the altitude tape. An amber check altitude label is displayed when there is a discrepancy in the altitude data from the different ADC sources. A red altitude fail message replaces the altitude tape when the barometric altitude data has failed. The vertical speed indicator is to the right of the altitude tape. Vertical speed is indicated by a green pointer against a fixed scale. Vertical speed is based on the inertial vertical speed measured by the ATR, as well as information from the air data system. In addition to the green pointer, the current vertical speed is indicated in green numerical format at the top of the scale. The indication is in hundreds of feet per minute. Descents are indicated by a minus sign. If the aircraft is at level flight, there is no numerical indication at the top of the scale. The crew can select the desired vertical speed by using the pitch wheel on the FGCP. The selected value is displayed above the altitude tape, in cyan. This value is also in hundreds of feet. In addition, the target vertical speed is indicated by a cyan bug on the vertical speed scale. If the aircraft is VNAV equipped, the FMS can control the selected vertical speed. In this case, the bug and readout are displayed in magenta. The TCAS system will display resolution advisories, or RAs, on the vertical speed indicator. The safe and unsafe regions are represented by green and red vertical bands, respectively. The green band is the safe vertical speed for the current RA. If your current vertical speed is in the red band, the numerical readout of the vertical speed will be displayed in red. The pointer will be displayed in red as well. TCAS is described in detail in the TCAS module. A red VS fail message replaces the vertical speed indicator when there is a failure of the vertical speed indicator data source. The center part of the PFD is the Attitude Director Indicator, or ADI. The aircraft is represented by a fixed symbol consisting of two wings and a dot. Aircraft roll is indicated by the top pointer and associated scale. Triangles and tick marks indicate 0, 10, 20, 30, 45, and 60 degrees of roll. Two green tick marks indicate a bank angle limit. The trapezoid under the roll pointer indicates the amount of slip. The aircraft's pitch attitude is indicated by tick marks. The tick marks are 2.5 degrees apart, up to 20 degrees. The tick marks above that are at 25, 30, 50, and 80 degrees. Note that in level flight, the visible pitch range is between -20 and +20 degrees. The bottom of the attitude indicator is colored brown. This represents the ground. In the event of a high nose-up pitch, the horizon will always be visible. If the pitch exceeds plus or minus 25 degrees, a large red chevron will be displayed. The apex of the chevron indicates the direction of the required correction, in order to return to a normal pitch attitude. Just like a conventional ADI, the flight director bars are displayed on the attitude part of the PFD. The flight director is followed by maneuvering the aircraft so that the intersection of the two flight director bars is on the dot of the fixed aircraft symbol. The vertical bar is the lateral command, and the horizontal bar is the vertical command. The horizon line of the attitude indicator has tick marks that represent heading. If the flight director bars are not displayed, a cyan tick mark will indicate the selected heading. The radio altitude is displayed on the bottom part of the attitude information. It is displayed in green when the aircraft's radio altitude is at, or below 2,500 feet. Decision height is displayed in cyan. An amber DH label is displayed above the radio altitude display when the aircraft reaches the decision height. The selected MDA is displayed in cyan, in the right-hand side. The selected MDA is displayed in amber when the barometric altitude is at, or below the selected MDA. A marker beacon label is displayed when the aircraft crosses over a marker beacon. A vertical deviation indicator is displayed on the right-hand side of the ADI when flying using an ILS or the FMS. The deviation is indicated by an icon against the scale. If the reference is an ILS, the deviation icon is cyan and V-shaped. If the navigation source is the FMS, the deviation icon is a hollow magenta rectangle. In this mode, the scale of the deviation depends on the phase of flight. Normally, a full-scale deviation indicates a deviation of 500 feet or more against the calculated path. During an approach, a full-scale deviation indicates a deviation of 150 feet or more. A lateral deviation indicator is displayed on the bottom of the ADI when flying using an ILS, the FMS, or GPS. If the source is an ILS, the deviation icon is also cyan and V-shaped. If the navigation source is the FMS, the deviation icon is also a magenta, hollow icon. In this case, the deviation scale also varies with the phase of flight. Normally, a full-scale deviation represents 5 nautical miles off course. If the aircraft is in the approach mode, a full-scale deviation is 1 nautical mile. An amber check attitude message is displayed when a discrepancy has been detected in the pitch or roll axis between AHRS 1 and 2. This message flashes initially for 9 seconds and then remains steady. In the event of a loss of the AHRS, attitude data is no longer available. In this case, the ADI will be replaced with a red attitude fail message. The bottom part of the PFD shows navigation information. Navigation information can be displayed either as a horizontal situation indicator or as a navigation display. In the event the MFD displays another page besides the ND page, such as a system page, the ND will be displayed on the PFD. If the MFD reverts back to the ND page, the HSI will be displayed on the PFD. If there is a TCAS event, the navigation area reverts to an ND rows format, with a range of 10 nautical miles. True airspeed, or TAS, and ground speed, or GS, are displayed in the upper, left-hand side of the navigation area. Wind speed is displayed in both numerical and graphical format. The current aircraft heading is indicated by a yellow triangle pointer at the top of the compass. The selected heading is indicated by the cyan heading bug. The selected heading is also displayed in numerical format. The aircraft's current track is indicated by a magenta diamond. Navigation source information is displayed on the right side of the navigation area. This is the navigation source selected on the associated side of the FGCP. The top line is the navigation source. It is displayed in cyan if the source is either VOR or ILS. It is displayed in magenta if the navigation source is the FMS. If the navigation source is from the opposite side, the source is displayed in amber. The second line is the source frequency, if the source is either a VOR or an ILS. If the navigation source is the FMS, the waypoint identifier will be displayed here. The third line shows the selected course. This is indicated by the white course label. If the navigation source is the FMS, the label is replaced by a white DTK label. The numerical value is the track commanded by the FMS. The fourth line indicates the distance to the navigation source, if VOR or ILS is selected. Otherwise, it represents the distance to the next active FMS waypoint. A cyan H label is displayed to indicate the distance to a DME station that is on hold. Bearing pointers are displayed within the compass card. One pointer is associated with the captain's navigation source, and the second one is associated with the first officer's navigation source. The captain's bearing pointer is represented by a single line, with a circle on one end. The label in the bottom, left-hand side of the PFD, is a reminder of what the number 1 course pointer looks like. The first officer's pointer is a double line, with a diamond in one end. The reminder for that pointer is in the bottom, right-hand side of the PFD. The color of the pointers depends on the navigation source. A pointer is white if the navigation source is the VOR, or green if it is the ADF. The type and frequency of the navigation station associated with each bearing pointer is indicated in the bottom left and right sides of the PFD navigation area. The PFD HSI incorporates a course deviation indicator, just like a traditional HSI. The outer part of the indicator points in the direction of the selected course. The inner part moves to indicate the amount of deviation from the selected course. The course deviation indicator is displayed in cyan if the navigation source is either the ILS or VOR. It is displayed in magenta if the navigation source is the FMS. The course deviation indicator turns amber in the event the deviation from the localizer is excessive. A triangle represents the to from indicator. The triangle is cyan if the navigation source is a VOR, or magenta if the navigation source is the FMS. Radar information is displayed on the right side of the navigation area. FMS messages are displayed in the left-hand side. If there is a difference between the headings on the captain's PFD and the first officer's PFD, the amber check heading message is displayed. In the event of an AHRS failure, the navigation area will be replaced with a red heading fail message. The engine and warning display, or EWD, is divided into 5 areas. The top left side shows trim settings, brake message test status, and flap position. The top right side displays engine parameters, including torque, NP, ITT, and fuel used. The section under the engine display is the permanent data. The bottom left-hand side shows alert messages. The bottom right-hand side shows procedures. The permanent data is always displayed. The data displayed in this area consists of total air temperature, or TAT, static air temperature, or SAT, flight time, current time, fuel on board, or FOB, and gross weight. The MFD is divided into 3 sections. The top section is called the MFD upper window. The bottom, left-hand side is the memo panel display. The bottom, right-hand side is the virtual control panel, or VCP. The memo panel display provides information on fuel crossfeed, anti-icing, de-icing, and seatbelt and no device sign status. The VCP is used to manage the navigation and communication radios, as well as the TCAS and transponder. The VCP is controlled by the Multifunction Control Panel, or MCP. The MCP is located on the center pedestal. The use of this panel is covered in the Communications module. The MFD upper window displays multiple formats of information, including navigation data, aircraft system pages, performance initialization data, engine run-up data, video, if the aircraft is equipped, and also an airport map, if the aircraft is equipped. The EFS control panel, or EFCP, controls the information that is displayed on the MFD. There are 2 EFCPs located on the center pedestal, one for each pilot. The information to display on the MFD is selected by pressing one of the 6 buttons on the left side of the EFCP. Click on the System button to display the system pages. Pressing the System button displays 4 system pages, including AC Wild Hydraulic, Engine, Cabin, and AC/DC Electric. Most of the time, you will use the MFD to display navigation data. Navigation information is selected by pressing the ND button on the EFCP. Click on the ND button to display navigation information on the MFD. On the side that is coupled, the navigation display, or ND, is displayed by default on the MFD. The MFD can display 3 types of navigation displays: the ND Arc mode, the ND Rose mode, or the ND Plan mode. The format to display is selected by using the Format knob. If the MFD display is changed, A mini ND page will be displayed on the associated PFD. Click on the System button to see how it changes the display on both the MFD and PFD. In all three navigation formats, the MFD will display true airspeed, ground speed, and wind direction and speed. An arrow also depicts in graphical format the wind direction. In addition, the arc mode and the rose mode show the aircraft's current heading, selected heading, and track. The plan mode is oriented to north, so heading is not displayed in this mode. The navigation information that can be displayed on the MFD is similar to the information that is displayed on the navigation part of the PFD. This includes bearing pointers and bearing pointer navigation sources. For both the PFD and MFD, the bearing pointers are selected on or off by pressing the bearing buttons on the associated EFCP. The range on the navigation display is controlled by the range plus or minus push buttons on the EFCP. The Multifunction Control Panel, or MCP, is used to control the overlay information displayed on the ND. Overlay information includes TCAS traffic, weather radar, terrain, navaids, and airports. Pressing the navigation button on the MCP opens the overlay page on the virtual control panel area of the MFD, where these items can be selected or deselected for display. If the headings displayed on the MFDs differ, the amber check heading label is displayed. As you have seen, differences between the left and right sides are indicated by amber messages. For example, the Check IAS label on the PFD speed tape indicates that there is a difference in the airspeed provided by the ADCs. In this case, you would want to switch the ADC source. This is done by pressing the ADC push button on the switching panel. Click on the Captain's ADC push button to switch the Captain's ADC source to ADC2. When the Captain's ADC push button is pressed, the Captain's instrument data source is switched to the first officer's source. SYS2 is illuminated in white on the Captain's ADC source button, and the green capt/2 caption on the first officer's ADC source button is illuminated. In addition, a yellow ADC message is displayed on the Captain's PFD. The number following the label indicates the ADC source. The AHRS source can be switched when there is a failure of an AHRS, or if there is a discrepancy between the two systems. The AHRS source is switched by pressing the Attitude heading push button. In this example, the Captain's AHRS has failed. Click on the Attitude heading push button to switch the attitude reference to AHRS2. When the AHRS source has been switched, the SYS2 caption illuminates in white on the Captain's side, and the green capt/2 caption is illuminated on the first officer's side. In addition, a yellow AHRS message is displayed on the Captain's PFD. The number following the label indicates that the Captain's side is using AHRS2. The Control and Display System, or CDS, provides both automatic and manual switching of the DUs. An automatic reversion occurs when a display unit fails, or it can be triggered by the Flight Warning System, or FWS. For example, when the aircraft is powered by the batteries, DUs 1, 3, and 5 are off. DU2 will display the EWD, and DU4 will display the engine system page. After engine start, the DUs display their normal information. The CDS will automatically reconfigure the DUs in the event a DU fails. The general rule is that if a PFD or EWD display unit fails, the MFD will revert to either PFD or EWD, respectively. This reconfiguration depends on the flight ground status of the aircraft and which side is coupled. The table on this screen shows the automatic reversion in the event of a single DU loss with no coupling. As it was mentioned previously, the FWS can also force a reversion of the DUs. For example, if the DU3 is displaying a PFD, the FWS can force DU3 to revert back to an EWD, in the event of a warning. Another example would be when a specific system page is shown on the MFD. In the event of an alert, the FWS can force the display of a different system display. The DUs can be manually reconfigured by using the associated display button on the switching panel. The display button on the captain's side affects DU2, and the one on the first officer's side affects DU4. Each press of the button cycles between PFD, EWD, and MFD. In the event DU1 or 2 on the captain's side fails, or DU4 or 5 fails on the first officer's side, the associated display button will enable reversion on the remaining DU. A failure of a DU will be indicated by a blank screen. If there is a software or hardware failure, the affected DU will display a large amber F. Standby instruments consist of a standby compass and an integrated electronic standby instrument, or IESI. The standby compass is located on the captain's side of the flight instruments panel, under the glare shield. This is a traditional magnetic compass. It does not require any type of electrical power or system inputs to function. This compass is normally stowed in the up position. It needs to be extended down by using the slider knob. The IESI displays attitude, airspeed, altitude, barometric pressure, VHF1 communication, and VOR1 ILS1 radio navigation. The IESI is powered by the DC Essential Bus, or the Hot Emergency Bus. Air data information is provided by the standby pitot and static sources. The brightness of the display is controlled with the plus and minus buttons on the left-hand side. The IESI display looks like a PFD. The airspeed is indicated by a speed tape. The current airspeed is indicated in the box with a pointer. The tip of the pointer points to the equivalent airspeed on the speed tape. The current Mach number is displayed under the attitude indicator. The speed tape will display speed limits. The current altitude is displayed on the right-hand side. The altitude is indicated in numerical format. The barometric setting is displayed under the altitude tape. The barometric setting is adjusted using the set knob. The aircraft slip is indicated by the trapezoidal index under the roll pointer. The attitude indicator is also similar to the PFD. The pitch scale has index marks every 2.5 degrees, up to 20 degrees of pitch. If the aircraft's pitch exceeds 25 degrees, a large red chevron will appear to indicate the required direction to correct the excessive pitch. The roll scale has index marks at 10, 20, 30, 45 and 60 degrees of roll. Localizer and glide slope deviation indicators are displayed when the ILS mode is selected. These deviation indicators are visible only if there is a valid localizer and glide slope signal. If the navigation source is a VOR station, only the lateral deviation indicator is visible. To and from triangle indicators are visible on the bottom left corner. In this situation, the current navigation and communication frequencies are displayed at the top of the instrument. These frequencies are associated with NAV1 and COM1 only. At this point, you are probably asking yourself, how do you change the frequencies or barometric setting? This is done by using the SEL and menu buttons and the set knob. Click on the menu button to change the barometric reference from inches of mercury to hectopascals. This will display a message at the bottom of the instrument. The message shown here indicates that the current barometric setting is in inches of mercury. To switch to hectopascals, you must first click on the set knob. Click on the set knob to continue. This will change the message so that both barometric setting units are shown, with a box, or cursor, around the currently selected units, which in this case is inches of mercury. Rotating the set knob moves the cursor to hectopascals. Pressing the SEL button will change the selected barometric setting units to hectopascals. Pressing the menu button closes the menu function. Once you exit the menu, you can adjust the barometric setting by rotating the set knob. ILS and VOR tuning is done in a similar fashion. Several flags are displayed on the IESI when there is a failure. The graphic on this screen provides a summary of these failures. The ATR is equipped with a cockpit voice recorder, or CVR, and a solid-state flight data recorder, or SSFDR. The two recorders are automatically powered and start recording when the aircraft is operating on its own electrical power. The two recorders automatically shut down 10 minutes after the engines have been shut down. If the aircraft is powered by an external ground power cart, the recorders are off until one engine is operating. Each recorder incorporates an underwater acoustic beacon. Beacon actuation occurs when the recorder is immersed in water. The effective range of the acoustic beacon is 3.5 kilometers. Once activated, the beacon is designed to operate continuously for a period of 30 days. The CVR continuously records all communications that pass through the Remote Control Audio Unit, or RCAU. The CVR will also record cabin crew announcements. In addition, the CVR will also record flight deck audio through an area microphone located below the overhead panel. This microphone will also record audio alerts. At all times, the CVR only retains the last 30 minutes of recordings. The Flight Data Acquisition Unit, or FDAU, collects information from various aircraft systems and converts them into digital format. The SSFDR records the digital data produced by the FDAU. At all times, the DFDR only retains the last 50 hours of recordings. The CVR panel, located on the overhead panel, is used to test the CVR, as well as to erase any information stored by the CVR. The CVR tape can be erased by pressing the red Erase push button. The tape will be erased, provided the landing gear shock absorbers are compressed, and the parking brake is set. The tape is completely erased by pressing and holding the Erase push button for 2 seconds. The CVR is tested by pressing and holding the green Test push button. This activates the test circuit, and the pointer in the adjacent indicator moves to between 8 and 10. If a headset is plugged into the panel, a 600 Hz tone will be heard through the headset. Movement of the pointer into the white band area indicates a successful test of the CVR. A recorder panel on the center pedestal has more controls for the CVR and SSFDR. The event button is used to mark a special event in the SSFDR. Pressing the ground control push button energizes both the CVR and the SSFDR. This is the manual mode of operation. When the manual mode is enabled, the blue on caption illuminates in the push button. The manual mode is disabled by pressing the reset push button. There are 2 clocks, located on either side of the flight instruments panel. The captain's clock is powered by the DC emergency bus, or the hot emergency battery bus. The first officer's clock is powered by DC bus 2, or the hot main battery bus. The clock is designed to operate as a chronometer as well. The chronometer time is indicated in minutes and seconds on the lower display. The chronometer function is controlled by pushing the CHR push button. The first push starts the chronometer. The second push stops the chronometer. The third push resets the chronometer. Elapsed time can be displayed on the EWD by pressing the Elapsed Time button on the right side of the Flight Instruments panel. Elapsed time starts counting when the aircraft is airborne.